not a trig function 1. Okay, we've got a set of parametric equations where x equals 1 plus t squared, y equals 2 minus t cubed. I first want you to be able to sketch this and make a table. We'll just make the table. Make a table from t equals 0 to 5. So we'll go by 1. So it's a 3-row table because you've got t, x, and y. So 0, 1, 2, 3, 4, 5. And you could just plug the 0. I think it might be quicker just to, instead of you grabbing the calculator, putting in the t. So 0 squared plus 1, 1 squared plus 1, 5, 9 plus 1 is 10, 16 plus 1 is 17, 25 plus 1 is 26. Okay, t cubed, 0 cubed is 0, so that's 2. 1 cubed is 1, 2 minus 1 is 1. 2 cubed is 8, 2 minus 8 is a negative 6. 3 cubed is 27, 2 minus 27 is 25. I think 4 cubed is 64. So 2 minus 6, oops, that was a negative 25. Let's see, did I do that right? 27, yeah. 2 minus 64 is a negative 62. And then 2 minus 5 cubed is a negative 123. Okay, make a table and then sketch. So x's are going from 1 to 26, y's are going from 2 to negative 123. So let's see, I think I will go by 5s here. 5, 10, 15, 20, 25. Well, let's see, I'll go by 10s here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, so first point, x is 1, y is 2. Next point, x is 2, y is 1. Then 5, negative 6. 10, negative 25. 10, 25. Oh, that was negative 10. That's going to be up a little bit there. Wrong spot. This was negative 10. Okay. Now I'm on, let's see, that was 10. 17. 5, 10, 50, 17, negative 62. 10, 20, 30, 40, 50, 62. And then 26, negative 123, about there. So I've got this going on. Okay, and you can graph that on your calculator if you need to. You can set the window up just like our table to see that you did it right, but I'm not going to take the time to do that. I want to find dy dx. And remember, both of our equations are in terms of t, so we've got to do that division of derivative of y with respect to t divided by derivative of x with respect to t. And when I flip and multiply, I end up with dy over dx. So I have to find the two derivatives and then divide them. That's the whole thing in a nutshell today, is take the two derivatives and divide. I think I'll use this space up here. So dy dt, also known as y prime, is going to be, derivative of 2 is 0, negative 3 t squared, and then dx dt, x prime, either one, derivative of 1 is 0, plus derivative here will be 2t. Now when I divide those, the y1 is on top, negative 3t squared, 2t. I can simplify by canceling out a t. This one's going to be gone, this one's going to be down to 1. So I get negative 3/2 t. Now can you find the derivative when t equals 1? So find dy dx when t equals 1. Well, that just means plug 1 in there. So y prime will equal negative 3/2 times 1, or a negative 3/2. And if you look, that's the slope of the tangent line when t equals 1, that's the second point right here. So it's a negative 3/2 slope. Now what I want you to do, we didn't do this in the first one because it was going to be too complicated. I want you to eliminate t from each equation and write y in terms of x. So, if what I need to do, I'm going to write them down here so I've got them visible. Plus t squared, y equals 2 minus t cubed. I want to rewrite this y equation so that it has x's in it instead of t's. Well, all I've got to do is get a substitution. If I solve this for t, I can substitute it back in over here. So that means just rearrange this one, get it t equals. So I'll subtract 1. So x minus 1 equals t squared. And to get t, I'm going to do the square root on both sides. And because I know I'm going to be doing derivatives here, instead of doing square root, I'm going to go to the 1/2 power on both sides, which is the same thing as square rooting. So that gets me t equals the quantity x minus 1 to the 1/2 power. Now I can take this and substitute it in here, and I'll have a y equation in terms of x. So y equals 2 minus the t, whatever t is, I need to cube it. And well, t is minus 1 to the 1/2, and I've got to cube that quantity. Well, all that means for me is just multiply these exponents together. Think of that as 3 over 1. So y equals 2 minus x minus 1 to the 3/2. Okay, we're almost there. Now I want to find the derivative here. Find dy dx. Show that the derivative value when t equals 1 comes out the same as it did in part C. So show same deriv at t equals 1. Okay, so we've got to do derivative first. So I'm doing the derivative of this equation right here. So y prime, derivative of 2 is 0. Now here I've got an inside, outside with a negative out in front. So when I bring this down, it's going to be negative 3/2 x minus 1 to the 1/2 power. Inside derivative of x is 1. I'm multiplying, I don't need that, and then that goes to 0. So it says show that it has the same derivative when t equals 1. Well, I don't have any t's in here. I have a value for x. So what I need to do is go back to my table. Well, when t equals 1, x was a 2. So if I substitute in 2, I should be getting the same derivative as I got in the other part. So I'm going to put 2 in for the x here. So y prime when x equals 2 is negative 3/2. 2 minus 1 to the 1/2 times 1, I don't care. So 2 minus 1 is 1. Square root of 1 is 1. I get negative 3/2. And that's exactly the same thing I got there. Okay, so this stuff really isn't that bad. Coming up with parametric equations is tough. And doing this thing here with the trig functions is near impossible, but when it's just non-trig, it's not so bad. So your homework is going to be what page? I don't know. Hold on. 163. 1, 2, number 3, parts A through C only. 5, B, 7, B, and 8, B. So that's it.